For this Show Me, we are asking Part A to draw an array on graph paper and use the array to explain why the partial products algorithm calculates the correct answer to 23 multiplied by 27. And if graph paper is not available, then just draw a rectangle to represent the array rather than drawing 23 rows of 27 items. So we'll start with Part A, and we have 23 multiplied by 27. And we'll just draw a rectangle to represent 23 multiplied by 27. Now the partial products algorithm, we'll go ahead and use that to find 27 multiplied by 23. So we first start with 3 multiplied by 7, which would give us 21. And we'll write out here to the side that that's 3 times 7. Now we'll multiply 3 times 2 tens because this 2 is in the tens place of 27. So we'll write 2 tens multiplied by 3, and that gives 20 times 3 would be 60. Same thing here. 2 tens multiplied by 7 ones, so 2 tens multiplied by 7 ones would give us 140. And then same thing for here, we have 2 tens multiplied by another 2 tens. So we'll write 2 tens multiplied by 2 tens, and that would give us 400. Now when we add all these together, we come up with a total sum of 621, which is our total. So 27 multiplied by 23 is 621. Now the way that this array can show how we got this answer and why the partial products algorithm calculates to the correct answer, you can divide the array, okay, into, so we have our array, so let's say this part is the 2 tens, and this part is the 3 ones, which would give us 23. And let's say this part is the 2 tens, and this part is the 7 ones, which would equal 27. So we'll write that up here. This is the same thing as this. And you can see once you draw it like this that each of these individual multiplication statements comes from this. So we have our 3 ones multiplied by our 7 ones, and our 2 tens multiplied by our 3 ones, our 2 tens multiplied by our 7 ones, and then our 2 tens multiplied by 2 tens. So that is how you could show that this array calculates to the correct answer of 621. So part B of this question asks us to relate the array that we drew for part A to the steps in the standard algorithm for calculating 23 multiplied by 27. So we do the same thing down here. So we'll multiply our standard would be 23 multiplied by 27. So in our standard algorithm, we would do 3 times 7, which would be 21. 7 times 2, 14, plus 2 is 16. So once we've used those, we mark those out, and we come down here and bring down our 0. 2 times 3 is 6. And 2 times 2 is 4. Once we add those together, we get 621, which is the same total we got up here. So we see that the standard algorithm is just a shorter version of what we did up here with the partial products algorithm. So if we use our same array that we used up here, I'll draw it again. So we have our 2 10s, 3 1s, and we have another 2 10s and 7 1s. So of course this is 23 because 2 10s and 3 1s is 23, and 2 10s and 7 1s is 27. We can see that when we multiplied the 7 times 3, which of course was our 7 1s multiplied by our 3 1s, and then we came over here and multiplied the 7 1s multiplied by the 2 10s, which of course would be 7 1s multiplied by 2 10s, and then we multiplied 2 10s by 3 1s, which would be the 2 10s multiplied by the 3 1s, and then of course finally the 2 10s multiplied by the 2 10s again. So basically the standard is just a shorter version of the partial, and we see that how this array shows how the standard algorithm is correct because you multiply the same individual multiplication statements as the first, which was the partial products algorithm.